So in this clip I will demonstrate how to set up a simulation to roll a pair of dice 1,000 times, add up their scores and look at the distribution of those scores. So we're just building on the work from the first video clip. So same start, we'll start by counting the number of throws, and we'll have one die, second die and a total. So the first throw, we're going to use the rand between function again, so equals rand between, and each die is going to come up with a random number between 1 and 6. So the second one, and then we want to total those up. So what we're going to say is equals, and we could use sum, but it's just as easy to click on that one, then press add, and that one. Centralize those. So you can see there, that will give us one throw of the dice. So while we're making sure it all works, if we just roll 10 times first of all, so I want to click on that, I want to get a series going. So 1, 2, 3, highlight those cells, go to the bottom right hand corner and drag down to 10, and then with these ones we can just fill those down. So there we've got two die being thrown twice, 10 times, and their totals. Now we want a group frequency table for those. So score and frequency. Now the combined score, the conversation with the pupils, we would include 1 to see how many times the score of 1 comes up, and of course get the kids to establish that that's impossible. So again, if I just drag that down to 12, those are the possible scores. And then we're going to use that countif function we looked at. But first we're going to define the range that we're looking at. So that's the range there. So I'm going to call that scores. So equals countif scores. So that's identified the range, and then we'll use the efficient way of showing what we're looking for. So open inverted commas equals and we want F2 close brackets, and as we'd expect that would show a 0. Now we can just fill that down because everything in there is linked, and that shows us what the scores are like over 10 throws. We could graph that. If we highlight the frequency there and insert bars, and we can see there at the moment it's not a very reliable distribution because we've only thrown it 10 times. So if we just delete that for now, and then we want to extend this down to 1,000 throws. So we just drag that down to there. That shows us that would be 1,000 throws, and then we can fill down the other columns. So there you go, 1,000 rolls of the dice. We now have to, if you remember from the first video, this is only defining scores up as far as the 10th throw. So we have to redefine that now. And we do that by going to Formulas, Name Manager, there's the name, and change that from D11 to D1001. And you'll see now that it covers the whole range of our simulation. So if we now choose to graph that, and you can ask the kids, or maybe they've already predicted what this distribution is going to look like. So insert recommended chart. Alright, that's picked up both. Hold on. Let's just undo that. And that's what we want to chart. And there you go. So that shows a really clear distribution over 1,000 throws. To show the repeated experiment, we'll add a little repeat button to re-roll the dice. So we go to Developer, Insert, Button, Form Control, create ourselves a little button, call it Rethrow or something. New, Calculate is the only bit of code you need to put in there. Calculate. Close that. Rename it. Rethrow or throw again. And now every time you press that, it will repeat 1,000 throws of the experiment, and you can see quite clearly how reliable that outcome is over many throws. So there you go. So that's using Excel to simulate the throwing of 2 die.